Hello friends. Well, before I talk about today's code, I would like to discuss something different. What is that? Well, summer is almost getting in. So, with the summer coming in, it means what? People would start ordering more ice cream, more cold drinks, isn't it? So I can say that as the temperature goes up, the sale of cold drinks as well as ice creams will also increase. What I'm trying to mean? Well, if summer is the variable x, then ice cream, cold drinks, these are variable y. So with the increase of x, gradually y is also increasing. Isn't it so? Yes. And that's what today's topic of discussion is. Correlation coefficient. Okay? The term is very big, but this is what the ultimate thing is that. What is the relationship between variables? Like with the increase in x, what is y behavior is? Is it increasing or is it not? That's what is been determined with the help of correlation coefficient. So I just gave a simple example to make you understand that how these variables are linearly dependent on one another, and eventually you get to find out the net result, the cell, the target, isn't it? So in order to carry on this particular discussion, I will be introducing a very popular dataset that is called Irish. So if you look at this dataset, first of all, it has got 150 rows, and this 150 rows is actually divided into three categories: Setosa, versicolor and virginica. Exactly 50 into 3, 50 rows for Setosa, 50 rows for virginica, and 50 rows for versicolor. That's how it's 150. So this is my target. You can say this is the cell, and these are all independent variables. So I have got four variables over here: sepal.length, sepal.width, petal.length, and petal.width. What we are trying to figure out is how much these variables are interdependent. Are they so? Who is dependent on whom, either in the positive way or in the negative way? That's what we are trying to figure out, the relationship in between these variables, and finally that will determine the resultant, whether it's a Setosa or whether it's a versicolor or virginica. That's what this particular topic is all about: correlation coefficient. Okay, and this is all will be done with the help of few wonderful packages that Python comes up with. The first thing is I have to read this CSV data, and that brings us to Panda. So Panda would give us an environment with the help of which the data from the CSV will be provided to the system in the form of rows and columns in the matrix format, or to be more specific, in the form of data frame, because it has got both rows and columns. That's the reason we can call it as a data frame. Let me comment this portion, and let me just uncomment this piece of code, and let me comment this one. So Python provided the package called pandas, with the help of which we read the CSV file, and it will provide us few top tuples. So let me run the code and let's see what output we are getting. I have given a wrong name. Let me give the name once again. So Python correlation underscore matrix dot py is a file name. I hit the enter. Yes, and now we can see the first 5 rows, and here we can see that these are the 4 independent features, and this is the target, the label, what we need to find out. Okay, so that's what the first part of the code goes. So we can comment the print part, and now I want to see how many rows are there in context to the target. That's what I want to see. let me clear the screen and let's run the code again, and it shows that there are 50 rows for Setosa, 50 rows for versicolor, and 50 rows for virginica. Okay, that's the reason it's 150 total number of tuples. That's great. Okay, so far so good. Now what we are going to see, as we just now saw, that the resultant output was in the form of categorical data. That means they're in the form of strings, but if we have to work on data manipulation, then we have to convert these data into a numeric form. Okay, so the label, we have to make use of label encoder that provided by sklearn. So what label encoder would do is it will convert Setosa to 0, versicolor to 1, and virginica to 2. Alphabetically it's coming off S, then followed by V. That's how the transformation would be taking place, and the resultant output, that means 0, 1, 2, would be finally assigned to the data frame whose label was, this particular label was target. There where it would be assigned. So let me just check out whether that actually been done or not. So I can again go for print, and let's print the total number of count. No, I need to print the count. Just let me print the rows, although it will just show me few rows only. Nonetheless, let's run the code, and here it comes. Yes, see, the first top 5 rows were shown where Setosa has been labeled as 0, and the last 5 rows has been shown where virginica has been labeled as 2. So that means we can understand that the conversion of the categorical information has actually been taken successfully, and we are getting the numeric form. Okay, so this is very important step which we need to do in order to move forward, otherwise it won't work actually. So let me comment the print statement, and now we come, well, before we get into, well, what should I say, before we get into the correlation part, let me show you that how these 3 category of data has been distributed, because after all there are 3 different categories. So we can say that this is like a classification, an ideal example of a classification based problem. So let us see that one, and then we'll get into it. Okay, so let me run the code now, and for that reason what we are using scatter plot over here. With the help of scatter plot, we have been able to classify that there is a particular segment of a particular category which has been considered as 0 means Setosa, 1 means versicolor, and 2 means virginica. So over here clearly it has been, we can able to categorize that there are 3 different type of data distribution that has been taking place within this particular CSV file, and that has been done by scatter plot. So if you see over here, we have made use of scatter plot that is provided by Seaborn. So from the package Seaborn, we are giving a call to scatter plot. Now if you notice this particular statement very minutely, here we have used the x-axis with the petal dot length, and y-axis is sepal dot length. Now this can be a very important question. Okay, don't go by the print statement. The print statement is actually wrong. I should be just writing over here like length and width. That would be much better way to represent, rather writing petal and sepal, because not always it's going to be so. Okay, let me close this and let me rerun the code once again, and now it is much better that it is just length and it is just width. Okay, so the question is, why did I opted for petal dot length and sepal dot length, in spite of the fact that there are 4 features are there? We could have gone for some other thing as well, right? But why did I opted for this? You know, honestly speaking, when I started working on this particular segment, initially I was having a lot of problems. It was very difficult for me to make out why these things are like this, unless and until I dip down into the topic of correlation, and then it became very clear to me that how this thing is working. So I'm putting a question over here, that why did I use these 2 features in context to access? Why didn't I opted for other features? Don't worry, you will be getting the answer to this question, and that answer is actually been provided by the correlation coefficient. And that is something what is the agenda of today's video. So for the time being, let me close this and let me comment this entire portion, and let me take you to the correlation matrix. And here is a very wonderful function that is the Python Panda is going to provide, that is called correlation. And this is the entire formula of the correlation. Okay, this is the standard formula of the Pearson correlation coefficient, but you don't have to solve this entire thing. Rather, you just give a call to the correlation, and this is actually going to solve this particular equation. Okay, so what is going to do? Well, let me run the code and you see yourself what is the meaning of this correlation. And here comes the entire thing. Well, I have rounded this into 2 place decimal, otherwise it would have been 4 or 5 place decimal. For our easy understanding, for better understanding, I just rounded it off. So data frame, the data frame is holding the target. Okay, and along with that the 4 other features are there. So data frame dot correlation, and I have given a call to the round off to 2 place decimal place, and I store it in this particular matrix, and that's what I'm printing. So if you see very minutely something quite important, you will notice over here. Look over here, the way this matrix has been plotted, and that's the reason why it is called correlation matrix, because it is in the form of 2D. So over here rows are there, and over here column is also there. So sepal.length and sepal.length, sepal.width, 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 petal.length, petal.length, and petal.width, petal.width, and then comes the target. So how are you going to read the data? Well, you read it in this way: sepal.length and sepal.length, that means it's same. That's the reason it's 1. Sepal.width and sepal.width will also be same. That's the reason it's 1. Petal.length and petal.width is 1, and petal.width and petal.width is also 1. Right? And target will always 1. So diagonally if you go, it will be always the very same. So that's the reason we will not go with that one. Rather, we will choose something else. Like for example, sepal.length and sepal.width, what is the relationship? Please notice very minutely. Sepal.length and sepal.width, what is the relationship? The relationship is in negative. That means increase in sepal length will not affect the width of the sepal. I repeat, the increase in sepal, it will not affect on the width. That's the reason it is negative. Whereas sepal.length increment will have a huge effect on the petals length. See, it's a positive, as we know that the value would range from -1 to that of 1. I repeat, from -1 to that of 1 would be the entire range of correlation. So over here 0.87, that means it has a very big impact. So with the increase in sepal length, the petal length will also increase. Similarly, the increase in sepal length, the petal width is also going to increase. So these are very strongly correlated. Now let's see over here, petal.length and sepal.length are also very correlated. Very high relationship is there. That means increase in petal length will also increase in sepal length. That's the reason this is all positive. That means those which are positive implies that they have a strong relationship. They have a very strong relationship, and that's the reason why. Let's get back to the scatter plot and let's see what we did over here. We have opted for petal.length. So petal.length and sepal.length. So as you can see, petal.length and sepal.length, they are very closely related. So it was positive 0.87. I can even go for petal.length and petal.width also. I can take it's 0.96. It's a very strong relationship it has got. So let me change this to petal.width. That also will work. So these are the strong positive petal.width. So now if I run the application, we will again see the entire clustering. We will see the clustering. See, let's see the clustering exactly. So that is very clear indication, because they are strongly related. As you can see, it's in positive direction. the value is in positive side, so that means there is a huge dependency between these two features. Petal dot length and petal dot width, they have a huge relationship. That means increase in petal length will also increase in petal width, and that's the reason why we opted for this, so that we can go and see the different classification that is taking place in among these three different groups. So with the help of scatter plot, we are trying to figure out what are the different clusters that is there in this particular data set. And while doing this cluster, or while forming this cluster, we have to go for those axes. We must choose those axes which are very much interdependent. That's the reason why you get a clear separation. See over here, the first one 0, this one represent the setosa, that means this is very closely associated. Similarly, versicolor is also closely associated, slight overlapping is there, but it is very closely neat and clean. And the same goes for virginica, very clearly it has its own clusters. So from here we can easily identify that there are three different clusters that this particular CSV file provides, and that's what the purpose of the scatter plot, to identify how well the classification has been done, and that is all done with the help of correlation. Now we have been seeing all this thing from the terminal. I do understand that terminal won't be so impactful, so for that reason what we now can do is we can go for something called heat map. Let me show you that. So in the heat map we can figure out something very interesting. So again, heat map will be provided by the Seaborn. So Seaborn is responsible for providing me the heat map. So let me run the code now from here. Let me clear the screen and let's run the code again and see what heat map is going to provide. The heat map is exactly going to provide the same thing what you were seeing in the terminal, but this is in a much better good looking fashion. So plt.figure, the figure size is width and the height, x-axis, and so what is the width and what is the height I have given over here. Now look over here, we are using the correlation matrix. So heat map needs the correlation. So we have already performed the correlation, and that's what we have been putting it as a first parameter, the correlation. Along with that we are providing the annotation so that we can see these numbers. So as we saw in the terminal, see over the same thing, sepal length and sepal length will be having 1, sepal width and sepal width will be having 1, petal length, petal width will be having 1, petal width and petal width will be having 1, target will also be having target 1. So that's the same thing what you are seeing over here, but this is a much better good looking fashion. So you are basically seeing the correlation matrix is going to provide us a relationship. That's what we were discussing a few minutes ago, that if I go for sepal dot length and petal dot length, it is very correlated, it's 0.87. That means it's having a positive correlation. Whereas if you look at this, sepal dot width and petal dot width is negatively correlated. So negative values over here, these are the one which are negatively correlated. That means any change would not affect one another, they are all independent, so there is no like the changes will not be reflected. So see how negative value, it's minus 0.12, right? But whereas if you look at this one, petal dot width and petal dot length is very closely related with 0.96. So that's what we are seeing over here. And since we have gone for the decimal place 2, we have gone for the line width. This is the gap that you are seeing, that's the line width. So this is very neat and clean correlation matrix that the heat map is providing us. Now as I was saying, that there is a correlation or there is a regression line, that also we can plot with the help of Seaborn regression plot. See over here, the regression plot by Seaborn. So how powerful Seaborn is. So Seaborn is providing us heat map, the Seaborn is providing us scatter plot, and Seaborn is providing us regression line. Let me show you now what the regression line is all about, and then you will understand. Let me clear the screen and let me run the code now, and you will see the regression line. Look over here. What the regression line is saying, the relationship between petal dot length, so petal dot length with that of petal dot width. So petal dot length and petal dot width, petal dot length and petal dot width, it having a value of 0.96. So very strong positive correlation. That's the reason, see, the regression line is moving from the bottom left to the top right. So this is a very positive correlation is there. And look over here, these are means like I should not say it's a positive correlation. It's a pretty strong correlation is there, because if I have to say it's a positive, then I have to go for petal dot length and petal dot length together. Then it will be, you will see that all these dots are on overlapping on the line itself. Let me show you that would be the perfectly positive correlation. So if I go for a petal length over here as well, then you will see that these are all overlapping. Just a second. Well, over here LENGTH, yes. Now let me run the code and you will see how these are just overlapping the line. Look over here, exactly. So this is what is actually the positive, highly positive correlation, very highly positive correlation, because it's as you can see over here, petal dot length and petal dot length is 1.00. So that means it's all on the same line, regression line. So that's the reason it's so high positive. So, but that is actually, like, doing this would not solve our purpose. We are trying to figure out the comparison. So if we go with like petal dot length width with that of sepal dot width, let's try out this one and see over here the negative value. Okay, petal dot width. So I will go for petal dot width and with that of sepal dot width. So it will be sepal dot width. Sepal dot width. Let's see this time what happens. Sepal dot width, and this is again a negative correlation. Okay, now let's run the code and see what happened this time. Look over here. See, they have got no association. All the like the data are just scattered all around. They have got no association with the regression line, and the regression line is sloping downward. So it's a drifting downward. So as it's sloping downward, that means that there is a negative correlation, and all the data points, they are scattered all around the graph. So that implies it's a negative correlation. So whenever you are picking up any of these combinations like petal dot length with that sepal dot width, or petal dot width with sepal dot width, or even sepal dot width with petal dot length, these will be all negative correlation. That means they don't have any association, and then you will find the graph been showing the scattered, and they are not at all associated closely with the regression line. But if I choose something which is again very closely associated, like petal dot length with that of petal dot width, will be very high. Or even if I go with this one, petal dot width with sepal dot length, that will also very closely associated. So let's go with this one before we wrap up this video, and I hope you got the hint what the thing is all about. So petal dot length with that of petal dot width, petal dot width. And let's run the code now. You see how see again it's very close to the regression line. That means, look over here, the setosa is so overlapping with the regression line. That means this is all a very positive correlation, and we can see why it is so positive correlation, because this is on the positive side. So the beauty of this particular video was to make you understand that how the features of our data set are so important, because you need to understand that these features, how they are interdependent among each others, and from there you have to find out which are the features that are interdependent, which are not interdependent, so you can discard them accordingly, you can seclude them accordingly basis of their dependency, and that is all done by Pearson correlation coefficient. And that was the agenda of this particular video, to make you understand that how Seaborn, Matplotlib and sklearn label encoder, we have used it, but over here we didn't go for training a testing data set like what I have over here in one of the video. I will be doing even this one also, trend test, I will be doing it. Until that part, in this particular video you understood the correlation matrix, how it is important in context with the features and the label for any given data set. Okay, so that's all from this video presentation. In my next video I will be talking about more about trend test split, how to do a training for a given model. Okay, until then, have a nice time. Bye bye.